Okay, so this is Law of Sines and Cosines Part 2. I'm finding another one in your packet. If you go to your, so this will help us with our review. Go to your review packet page. Well, I don't know what page it's on, but it says Law of Sines and Cosines, and it's a few pages back, and you can find it real easily if you see these like boxes. I'll show you what the boxes mean. So I'm going to do number 1. A is 67 degrees, little a is 100, and little c is 125. So there's like lots of kind of messy work going on, and so like on our last slide. And so what I like for my students to do is to write their answers in here. Like I have an A and an A. So the first thing I'm going to find is angle C, then angle B, and then little b. But there could also be another angle C that's an option. So there's a place for like the 2 triangles that I just showed you in the animation that could work, like with an obtuse or an acute angle. And so I want all your answers to go in the box and your work can just be around it. That way when I'm grading your exam, if all the answers are correct, I don't have to plow through all of your work. All right, I'm going to say A over sine A. Of course, if your answers aren't right, I'll plow through your work looking for partial credit. Equals C over sine C. So I'm going to cross multiply. 100 sine C equals 125 sine of 67 degrees. So I have sine of C as 125 sine of 67 degrees over 100. So now I'm going to type that in to find sine C. All right, so I'm going to go, what are my numbers? 125 sine 67. I've checked my mode already. Divided by 100. Close your parentheses. Divided by 100. And now, even though it didn't come at me inverse sine, I'm going to have to unfortunately use inverse sine. And it'll only check the first quadrant for me. Oh, look at this. There's not going to be a triangle. Because when I go to, sine can't be 1.15. It can't be that big. Sine can only go up 1 and down 1. But if I push second sign, if you didn't notice that, second sign of answer and go enter, I'll get error. And so do you remember in the animation where it had that one and the, you know, like the, went like this, and this side wasn't even big enough to make a triangle. It was just swinging back and forth. It wasn't big enough to even reach the side. So this one, you could just do this on your boxes and go no triangle, there's no solution. Also, you might have known that ahead of time. A triangle can only have one obtuse angle, which makes sense. Let's say if I have an angle that's 100 degrees, the other two, the angles of a triangle can only add up to 180. And so if you subtract the 100 degree angle, the other two can only add up to 80. In other words, like it's impossible to have 2 acute angles. You'd have too many degrees. Like your first acute angle you'd encounter would be 91, and already those 2 angles, there's no room for a third one. So my point here is, if you remember geometry, little c is bigger than little a. That means angle C is going to be bigger than angle A. And now I'm wondering if I did something wrong, because this does look possible. So let me rework it and make sure I did it right. Because it is sort of, you can get no triangle, but second guessing myself here to make sure. I'll tell you what, let me check my answers before I rework it. All right, so, which I'll post the answers soon. Yeah, my explanation there about the obtuse really doesn't apply to that. Yeah, that one's a no triangle. So, so that one's not possible. But you run into it with your error message. Oops, sorry. You run into it with your error message here. All right, so now in your packet, let's go to number 2. Or the second one under law of sines and law of cosines. All right, so I have A is 50, So little a is 50, little b is 26, and angle A is 95. All right, so I'm going to say law of sines because I have two of the same letter. A over sine A equals B over sine B. So I'm going to say 50 sine B equals 26 sine 95. Divide by 50. You get sine B equals. All right, so let's say 26 sine 95 over 50. Clear. Okay, so 26 sine 95 divided by 50. All right, then I push inverse sine. I know it's going to give me the acute angle. And so it's 31.199 or 0.120. So in these boxes on your sheet, let's get ready for angle B1 and angle B2. So there's two possible triangles I can build with this. And so it just checked the first quadrant and gave me 31.199 degrees, or 31.120, you could round it. Right away, to find the second triangle, you could subtract that number from 180, because there's also an option in the second quadrant. Let me grab that, enter, enter. So I get 148.800. So my other option is 148.0, what? 800, wait. 148.800. Alright, so what happened is it could also be this angle over here. And so there's two triangles that I could make. I could make an acute triangle, or I could also take the same given statements and have an obtuse triangle that's also viable. Alright, so now that I have those numbers, let's go back and build this one. The angles of a triangle have to add up to 180. So I have 95. If I put it with the 31, with the acute angle, I'm going to see what the other angle could be. So, or it could be right here. Okay, so I'm going to say the angle that I'm given has to be 95, and one of the angles that I found, so I'm going to say 95 plus the 31. I'm going to subtract that number from 180. And I get 53.800 degrees. And then I can find little c back with the law of sines. You couldn't use Pythagorean theorem with a, b, and c because it's not a right triangle. So I would say c over sine c equals, let's go back to a over sine a. So I'm going to cross multiply 50. Notice how I'm not rounding off. I keep using the long numbers. So I'm going to say 50 sine 53.8, 50 times the sine of this, divided by the sine of 95. And little c that goes with that triangle is 40.502. The side, 40.502. All right, because when I cross multiplied, I would have sine 95 times c equals 50 times the sine of 53.8, and then divide by the sine of 95. That's what I did on my calculator. Okay, so this is one triangle that's possible. Now, that's if I used this angle. What if I decided to use this pretty obtuse angle here? I could also use it and build a whole nother triangle. So now I'm going to say 95 plus 148. Now watch what's going to happen. So I'm going to say 95 plus, I'm going to go up here and grab this 148, enter. And that's way too many degrees. Like I can't subtract that from 180 and get another angle. And so that one, we tried to build a second triangle and it failed. And so I only have one triangle here. Now there's a way to know that ahead of time, is that if you already have one obtuse angle, there's no way I could have another obtuse angle. So you might notice ahead of time if you really are on your game there. And in class we'll do one, we'll do some more of these. Let me do one with the law of cosines. Let's look at, let's go back to your sheet. Which one did I just do? Let's see. I have a lot of law of sines on here. Okay, so I'm going to do one where I have this one. It's the next to last one, I think, in the law of sines and law of cosines, where you have angle A, angle B, and angle C. This is 32, and this is 53, and this is 46. Okay, now there's a way to miss these problems, but I'll help you avoid it. All right, so I have little b is 32, opposite little c is 53, and angle A is 46. So do you see I have three different letters, a, a B, and a C? So even if I tried to use law of sines, I couldn't do it. I wouldn't have enough information. If I put B over sine B and C over sine C, or A over sine A, I would have all these unknowns. I wouldn't be able to do it. So I'm going to law of cosines. And since I have angle A, I'm going to start with the letter A. A squared equals B squared plus C squared minus 2BC cosine A. So I'm looking for A squared. A squared equals B squared plus C squared minus 2B C cosine of 46. So I'm just going to type that straight into my calculator. Again, you'd want to check your mode. All right, so I'm going to have where'd the slides go? All right, now where's the calculator? All right, so I'm going to have 32 squared plus 53 squared, 32 squared plus 53 squared minus 2 times both of them, 32 times 53, and then it ends with cosine of angle A. So cosine of 46 degrees. Now, this is not A, this is going to equal A squared, 1476.7188. So A squared is 1476 point whatever I just said. 7188. Alright, so let's square root that, which gives us plus or minus, but we're looking for the side of a triangle, so we'll definitely take the positive one. So I'm going to square root that answer, again not rounding off, second square root, and I'm going to pull this in, and so it's 38.428. So little a is 38.428, and that's a size. Okay, now I have little a, so I can go to law of sines. 38.428 A over sine A equals I'm going to either find B over sine B or C over sine C. I would find this one first because I know that B is the smallest side, and law of sine works really well for acute angles. So I'm going to say 32 over the sine of B. I'm not going to finish this one, but you can cross multiply and find angle B. So let's write our box. Little a is 38.428. You're about to find angle B and then angle C. I'll give you those answers. I think I have them here. Oh, wait. Oh, yeah, that's right. Okay, 38.428. Angle B ends up being 36.799 and 97.201. Now look, why did I cross the second one out without even trying to work it? With cosines, arc cosine checks the first and second quadrant. With all of this adding and subtracting, there's a chance that you could end up with some sort of a negative before you push cosine. The good news is law of cosines has no what we call the ambiguous case. There's really not another option because what happens with sine is it checks 1 and 4. But so it never checks all the way up to 180 degrees. But cosine checks quadrant 1 and 2 for you, and it was prepared to give you an answer. And so it checked the first quadrant and found 38.428. Again, we can talk about that more in class. But the good news is, if you're using law of cosines with 3 different letters, a second triangle is not even possible. It also has something to do with the hinge theorem that you learned in geometry. If you have 3 different letters, you know 2 sides and the angle between them. That's like set in stone. Things can't like swing around. What happens with law of sines is if you know, let me go back. When you have 2 letters of the same, 2 of the same letter, like this, when you have an A and a C, let's draw a triangle, A, B, C, A, B, C. Look what happens if you have an A, and a little c. Do you see how you don't have any idea how this is hinged together? Like you don't know, I'm sorry, you know this angle. You're going to go find this angle, and you have no idea how things are hinged together that you're looking for. You also don't know how this is hinged together, and so you don't know this angle. If I knew this angle, it wouldn't be ambiguous. But we can talk about it more face-to-face in class. So that helps you some with your review.